Okay, so we're going to be starting up our next chapter over equations and inequalities. So it kind of has to do with what we talked about with expressions. There's going to be variables. We're going to have to use these expressions, equations with variables in them. But equations are a little bit different. Okay, so as we get started with one-step equations, an equation is a math sentence or a statement in math that says that two quantities, two things are equal. And remember with expressions, we said that expressions did not have an equal sign. Well, an equation does. So the difference between an equation and an expression is that an equation has an equal sign, and it kind of has the word equal there in its word, in the word equation. And then we're going to be having to find the solution of the equations. And so if it says to solve or find the solution, that's just the answer to our equation. And so our goal is to find what the variable is. So x equals a number, or y equals this. That's the goal that we have. And so that's what we're going to be trying to do as we solve these equations. So if you need to pause and finish getting these two definitions down, go ahead and do that. Okay, and moving on, equivalent equations. We've talked about equivalent fractions. We've talked about equivalent expressions. Equivalent equations, pretty much the same thing. They're two equations that have the same solution. So equations could look much different, but if they have the same solution, then technically they are equivalent equations. And then a coefficient, we've talked about this one before, but just as a reminder, we're going to be seeing and talking about coefficients. That's the number that goes in front of a variable. So a coefficient is the number that goes in front of a variable, like 2x, 2 is the coefficient, or 1/3 y, 1/3 is the coefficient. That's the number that's in front of the variable. All right, if you need to pause and finish getting these down, go ahead and do that. But as we solve equations, solving these one-step equations, our goal for solving these types of equations is actually going to stay the same no matter if we have a 2-step, a 3-step, a 10-step equation. The goal when we solve equations is always the same. We want to have the variable on one side of the equal sign and a number on the other. For example, we want x equals 2 or y equals -7. The variable by itself, nothing else with it, on one side, and then a number on the other. And it could be switched as well. It could be 2 equals x or -7 equals y. That doesn't matter which side the variable's on, but that's our goal. Okay, so as we are getting it to this point, we only want like terms on the same side. So we want all of the variables, all of the x's or y's on one side, and then all of the numbers, the constants, on another side. So we want all like terms to be on the same side of the equal sign. And so to do that, we have to sometimes get rid of unlike terms or coefficients. And so we're going to perform the opposite operation of what you are doing. Perform the opposite operation of what you are doing. So this next slide kind of explains what I mean. So the opposite operation, so if we are adding 5 on one side, x plus 5, to get rid of that plus 5, we're going to subtract 5. That's the opposite of adding. If we are subtracting 7 and we need to get rid of that -7, we're going to do the opposite operation. We're going to add 7. If we are multiplying by 3, we're going to do the opposite, and we're going to divide by 3. And then if we're dividing by 2, we would do the opposite of dividing, which is multiply by 2. So whatever we need to get rid of, we're going to look at the operation that we're doing. If we're adding, we need to subtract the same thing. If we're subtracting, we need to add the same thing. And that's going to allow us to get rid of these unlike terms. And I'm going to show you, when we start doing some examples, I'm going to show you why this works, why we can do the opposite operation, and it's going to help us get what we need. Okay, and then finally, the last thing is, so to get rid of unlike terms, we do the opposite operation. And then, if we do something to one side, we have to do the same thing to the other side of the equal sign as well. So if we subtract 5 on one side of the equal sign, we've got to go to the other side and subtract 5 also. If we divide by 4 on one side, we've got to divide by 4 on the other side. If we add 4, we've got to add 4 to the other side. If we multiply by 3, multiply by 3 to the other side. So to get rid of something, we perform the opposite operation. Whatever operation we do to one side, though, we've got to do the same exact thing to the other side of the equal sign as well. All right, so let's start up and look at some examples. So it says to solve the following equations, I'm going to show you how to check your solution here in a second. But notice we have x plus 6 equals 4. Well, there is an x and a plus 6 on the left side of the equal sign. We just want x to be by itself. So what do we need to get rid of? Well, we need to get rid of the plus 6. So we are adding 6, which means we've got to do the opposite to add, which is subtract 6. So the way that I'm going to write this, I'm going to write a minus 6 under that 6. Okay, and then I don't have to do anything to the x because this is one side of the equal sign. So on the left-hand side of the equal sign, I subtracted 6. I've got to go to the right-hand side, and I've got to subtract 6 from that side as well. So notice what happens. Think about this as a math problem. X, nothing happens to it. It stays the same. We have positive 6, minus 6. 6 minus 6 gets us 0, right? So I'm going to write plus 0, x plus 0, equals 4 minus 6. 4 minus 6 is negative 2. Well, the last thing is, if it's x plus 0, if you're adding 0 to something, is that going to change it? It's not going to change it. And so we can actually get rid of those plus 6 and minus 6. We don't need to write that plus 0, okay? So all that we need to do to finish off is to say x equals negative 2. We have x by itself, nothing else with it, and then we have a number on the other side. That tells us that we're finished. Once we have x equals something, we're done with solving that equation. Okay, so we're going to these cancel out because plus 6 minus 6 gets us 0. So that's going to take those away. We're left with x equals 4 minus 6 is negative 2. The way that we can check our answer, just to make sure that it works, is if I plugged negative 2 in for x, because x is negative 2, and added 6, negative 2 plus 6, that gets me 4. So that would make that equation true. Okay, so our next example here, I have x minus 2 equals 1. Well, on the same side as x, there is a minus 2. To get rid of subtracting 2, I do the opposite operation. The opposite of subtraction would be addition. So I'm going to write that plus 2 under the minus 2. But remember, if I add 2 to one side of the equal sign, I need to add 2 to the other side as well. Okay, so x stays the same here. Minus 2 plus 2 is 0, so I can just cross that out. And then equals 1 plus 2 would be 3. So, to write it, finish that off, I'd have x equals 3. And if I were to plug this in, 3 minus 2 does give me 1. So that is correct. Okay, so I'm performing the opposite operation. If I do it to one side of the equal sign, I have to do the same thing to the other side. So pause the video and do these two on your own. All right, so for this one, this first one, actually for both of these, notice that the variable is on the other side of the equal sign from the first ones that we did. Nothing's going to change. We're still going to do the opposite operation to get rid of that number. And if we do something to one side of the equal sign, we've got to do the same thing to the other side. None of that's going to change. So right now, on the side that has b with it, I want to get b by itself. Right now, there is a plus 8 on that same side. The opposite of plus 8 is minus 8. So I'm going to write minus 8 to get rid of that 8. If I did it to the right side of the equal sign, I need to go over to the left side of the equal sign and do minus 8 on that side as well. So the plus 8 minus 8, that goes away. I'm left with b, which is what I want. So the last thing that I need to do is minus 5 and minus 8. Negative 5 minus 8, that's going to give me negative 13. So negative 13 equals b. If you want to write it like this, b equals negative 13, you could also do that. You can always switch around what side they're on the equal sign. Okay, so the same thing here. Look at the side that has the variable on it. Right now, the right-hand side has a z. So I need to focus on this side right now. Okay? So there is a minus 8 on the same side as that z. The opposite of minus 8 is plus 8. And if I did plus 8 to the right-hand side, I'm going to come over to the left side of the equal sign, and I'm going to do plus 8 on that as well. So minus 8 and plus 8 can cancel out. I'm left with z on the right-hand side. 12 plus 8 gives me 20. So z equals 20. That would be my answer. All right, so that's one type of problem with adding and subtracting. Another type of one-step equation that we're going to see is if we have a coefficient in front of our variable. So this first one, negative 8y equals 24. So there's no operation that goes in front of the negative 8 and y. So think back, remember what operation is it if there's nothing in between the two numbers or the number and the variable? Well, it would be multiplication. So this is like saying negative 8 times y equals 24. Okay, so if I am multiplying by negative 8, I want to get rid of that negative 8 because I need to get y by itself. So to get rid of that negative 8, I'm going to do the opposite of multiplication, which is division. The way that we write division with equations, we do not write the division sign with the two dots and the line in between them. We write it as a fraction. So whenever I say I need to divide negative 8, I am going to put a negative 8 under the 8y, the negative 8y. Okay, if I had just divided by 8, there would still be a negative sign there, and I always want my variables to be positive. It needs to be just y, not negative y, just y. Okay, so I'm going to divide by everything that's on the same side as y, which is that negative 8. What's negative 8 divided by negative 8? Well, a number divided by itself is going to get us 1. So what I'm left with here, it can cancel out. I'm left with 1y. And instead of writing 1y, I'm just going to write y. Okay, so just y equals, if I divided by negative 8 on the left-hand side, I've got to divide by negative 8 on the right-hand side as well. 24 divided by negative 8 is going to get me negative 3. Negative 3. And if I plugged in negative 3, negative 8 times negative 3 does get me positive 24. Okay? So now let's look at our next one. We have x over 4. Remember I said a fraction in an equation is the same thing as division. So this is x divided by 4. Now I can make a note of that. A fraction is really division in an equation. So if it's x divided by 4, I want x by itself, so I need to get rid of this divided by 4. The opposite of division is multiplication. So I'm going to multiply 4 on both sides of my equal sign. And I'm going to put the 4 either to the side or up top here with the x. I can just write it like that and that would be fine. So I have 4 times something and then it's divided by 4. Well, what's 4 divided by 4? That can cancel off because I'm left with 1x. It's kind of like saying this one up here. So I'm left with 1x equals 9 times 4 is 36. And 36 divided by 4 will give me 9. So if I am dividing something, if it looks like a fraction, the way that I get rid of that is I'm going to multiply both sides by the number I'm dividing. Okay? So go ahead and do both of these on your own. Pause the video. All right, so our first example here, we've got negative 6a equals negative 48. I need to get a by itself. So the way that I would get a by itself is to get rid of everything on the same side as a, which would be that -6. This is -6 times a, so I'm going to divide both sides by -6. So I would just, as soon as you do something to one side, go ahead and write it on the other side so you don't forget to do that. -6 divided by -6 is 1, so those can cancel out. And we're left with a equals -48 divided by -6 would be +8. So a equals +8. All right, and then our next one, 30 equals b over -6. Go straight to the side that has the variable with it, which is right here. Okay, b over -6 is b divided by -6. To get rid of division, I'm going to multiply both sides by that -6. -6 divided by -6 gives us 1, so that's going to cancel out. We're left with b on the right-hand side. -6 times 30 would give us -180. So -180 equals b. That would be the answer for that one. Okay, so that is just solving one-step equations. And we're going to get more practice with that as we go on. All right, I also want to look at a couple examples of writing one-step equations. So we'll just read this first, and then we'll go through the steps. So first of all, an angelfish can grow to be 12 inches long. If an angelfish is 8.5 inches longer than a clownfish, how long is a clownfish? So write an equation and then solve the equation to find the length of that. First thing, whenever we write an equation, one thing I want you to write is, say this: you need to have a number on the same side as the variable. So whenever we write an equation, whenever a question says write and solve the equation, we need to make sure we write a number on the same side of the equal sign as the variable. If I didn't do that, then I wouldn't be able to show the teacher, whoever's grading it, that I know how to solve the equation as well. Okay, so make sure there is a number on the same side as the variable. So first step is going to be like what we did when we wrote expressions. First step that we need to do is define the variable. And the good thing about this is it's almost always going to tell us what we're trying to find. So notice what we're trying to find here, how long is a clownfish? So we'll say C represents clownfish. Clownfish length. Okay, next thing is we're going to then figure out, okay, what number goes with C? So I take the clownfish length, and an angelfish is 8.5 inches longer than a clownfish, so I'm going to do C, the clownfish, plus 8.5, because that's going to be 8.5 inches longer, so we have to add. And if I take the clownfish plus 8.5, I should end up at 12 inches long, because that's how long the angelfish is. So that's our equation. The next thing that we will do is solve it. To solve this equation, we want to get rid of that plus 8.5. In order to do that, we would subtract 8.5. So 8.5 minus 8.5 gives us 0. C equals 12 minus 8.5 would be 3.5. Okay, so we get C equals 3.5 there. All right, so this next one, I want you all, we'll do this one together as well. Okay, so Lauren sent 574 text messages last week. Write an equation to find how many messages she sent each day. So it's almost always going to say, write an equation to find something. What are we trying to find here? That's going to tell us what our variable is. When we define the variable, that's going to tell us what it is. To find how many messages she sent each day. So we'll say M represents messages. Okay, so think about this. She sent 574 text messages last week. we're going to try and figure out how many messages she sent each day. So there is going to be a number with that M. We're talking about weeks and days. How many days are in a week? Well, it would be 7. So 7 is going to go in front of the M. 7 times the number of messages she sends each day should end up at 574. So that would be our equation. 7m equals 574. Okay? And we'll go ahead and solve this one as well. So divide both sides by 7. And we would do 574 divided by 7, which gives us 82. 82. So m would equal 82. All right, let's look at this next one. It says Tina travels 60 miles per hour for 3 hours. Using this equation, distance over time equals rate, find how many miles Tina traveled. So we're trying to find how many miles she traveled. The number of miles she traveled, is that the distance, the time, or the rate? The number of miles she traveled would be the distance. So we're trying to find distance, so we'll say that's D. We don't know what that is, so D is going to go on top. Over, what is the time? How long did she travel for? Well, she traveled for 3 hours, and that's going to equal the rate. The only other number we have left is 60 miles per hour, and that is a rate. Remember, a unit rate, miles per hour? So that's what our equation is going to look like. They kind of help us out, telling us what the form is going to be in, but D over 3 equals 60. To solve this equation for D, we're dividing by 3, so we need to do the opposite of division, which is multiply both sides by 3. So 60 times 3 as well. What happens to these 3's? Well, they cancel out, and we're left with D equals 60 times 3, which is 180. So that would be the answer to our equation. Okay, and then our last one with writing that equation. It says a pair of shoes costs $25. This is $14 less than the cost of a pair of jeans. Write an equation to represent the situation, then solve the equation to find what? To find the cost of a pair of jeans. So that's what we're going to be finding, okay? Which means, we'll say J for jeans, cost of jeans. Okay, so we know that there's going to be a number on the same side as J, because there needs to be. Okay, so if we're thinking about $14 less than, less than is what operation? Less than is subtraction. Okay, next question I've got is, which one costs more? The shoes or the jeans? Read that carefully. A pair of shoes costs $25, and $25 is $14 less. So the jeans actually cost more. So to find the amount, the cost for shoes, I would take the cost of jeans, less than means subtract, and subtract $14. And when I do that, I should end up at the cost of shoes, which is 25. So that would be our equation. J minus 14 equals 25. Okay, so then to solve that equation, I would add 14 to both sides because I'm doing the opposite operation. If I subtracted here, I need to add to get rid of it. Those are going to cancel out. I'm left with J on one side. 25 plus 14 gives me 39. So J equals 39. The cost of a pair of jeans is $39. Okay, so that's one step equation. And I know that seemed like quite a bit. We're trying to combine a little bit together. So big thing is when you're solving an equation, remember to get rid of something because you want to get rid of everything on the same side as the variable. You do the opposite operation. Whatever you do to one side of the equation, you got to do to the other side of the equal sign as well. So you can go ahead and get started on your practice problems. Hopefully you've got it down.